everyone. Welcome to the second half of the Data Science Festival. So we now have, well, you've had 4 talks this morning. You've got four more talks this afternoon. Don't know why I can't get the word out, sorry. Hope you've enjoyed your lunch. Nice warm lunch today for the first time at the Data Science Festival. This is the 8th time we've run it, and this is the first time we've had a hot lunch. So, enjoy that. Hope you've also kind of walked around and seen what's going on. There are a few competitions going on downstairs at the different stands. There's also a competition being run by the Data Science Festival. Now, if you've been taking pictures of the event, can you tag it on LinkedIn, tag the Data Science Festival, the company. So I think you've got to put spaces in it, Data Science Festival, and then hashtag it as well. And I think the hashtag is DSF. I don't know what the hashtag is, sorry about that. Hashtag it as well, and then you will be in the running for the competition today. Now, there are quite a few goodies in that, including a DSF backpack, a £100 Amazon voucher, a Chili's bottle, and a speaker. Now, I'll remind you about this competition again, so that's on today. So get your picture snapping. If you enjoy this talk, take a picture of that if that's your favorite part of the day. There's also another competition if you've been in the beer garden bit. If you play a couple of games, you might get a raffle ticket or a few raffle tickets, depending on how generous our game master is. And that's also being announced at 5 p.m. today here in this room. So, without further ado, we're going to go on to our talks. Our first speaker this afternoon is Dónal from Bumble. Dónal is an experienced data scientist working within the recommendations team at Bumble, within Bumble Inc. He has previously worked for Polynex. Have I said that right? Yeah. Paddy Power, Betfair, Accenture, and EY. If you could please welcome Dónal, please.
Thank you. Good afternoon, everyone. Can you hear me okay? That's good. Hope you had a nice lunch. Hope you're not in a post-lunch slump right now, but hopefully this will be some interesting material. So, as mentioned, I'm here on behalf of Bumble Inc., and I'm talking about our best photos feature. So the presentation title is Better Photos, and then it has the lofty subtitle of Leveraging Product Insights to Optimize Machine Learning Models. Now, given that's already piqued your interest enough to be in attendance, I will admit it is somewhat of a lofty or self-aggrandizing subtitle. I won't be delving too deeply into statistics. I'll be speaking more to how the combination of product insights, when applied to machine learning models, can lead to impressive results for members. So I'll briefly give an introduction to myself. I'll then talk about the importance of photos in the dating app space. I'll talk about how our best photos feature behaved when we originally launched it. I'll reveal an unrelated product insight that gave an inspiration for an iteration to the feature, and then I'll speak to the uplift that iteration achieved across a variety of metrics, and then we'll do some Q&A. So hi, I'm Dónal. As you may have guessed from the name and my accent, I'm Irish. I hope my accent is interpretable. I can't promise as much during the rugby this evening. My own background is in psychology. So I believe there was a talk earlier on about breaking into data science from a non-STEM background. I myself am a huge advocate of the atypical background in data science and how a diverse skill set can be additive. A lot of my undergrad was spent running hypothesis testing for experimental trials. Little did I know that this would become very relevant to a future career analyzing A/B tests with sample sizes that you could only dream of in the social sciences most of the time. And as mentioned, I work in the recommendations team in Bumble, so we're in charge of the algorithm compatibility, showing you the right people at the right time. A little bit more about Bumble Inc. So we're a constellation of apps. You may have heard of some of them, you may not have heard of others. We've acquired a couple of apps in recent times as well, Fruits and Official, and we've built Zodia in-house. So we're quite a cool company. We're women first, we have a strong commitment to safety, and we have offices in London, where I'm based, Barcelona and Austin, and we're currently hiring, so more about that later on and at our booth. So just to give you an insight into the global scale with which we operate, we're in more than 190 countries. We've had over 600 million users across our apps in our lifetime, and we have a little over 1,000 employees at the moment. So this is to say that we have quite a wide-reaching impact in a lot of different places. I'll give you a little bit of info on the structure of the data science practitioners at Bumble Inc. So I'm in the recommendations team, but we also have a trust and safety team. We hosted a Data Science Festival sandbox session in June on the topic of using AI to foster kinder and safer connections online. So there's a lot of interesting and innovative work happening on the AI front and the trust and safety side of things. In October of last year, we open sourced our private detector, which automatically detects and blurs lewd imagery. This allows us to be one of the few dating apps where you can send images in chat. And we do a lot of proactive work blocking bad actors, spammers, and scammers on the site. So there's a lot of interesting machine learning innovations in this space, some of which are related to imagery. However, for the presentation today, I'll be focusing more on the recommendation side of things. So as I mentioned, that's the team in which I sit. We're responsible for the algorithm, compatibility, and user experience in a more holistic sense. Then finally, we have a growth science team. They're in charge of more CRM initiatives, coming up with targeted promotion cycles, trying to calculate LTV and churn modeling. So now, the topic of today's talk is better photos. So why are photos important in the dating app context? So you may have heard of, there's a few websites out there where you can get ratings on your photos that you intend to put on your dating app. So an example of one being Photo Feeler. So these sites work by allowing people to upload images that they're considering putting on their dating profile and literally get feedback from strangers on the internet on them across a variety of dimensions. So I think the existence of such sites and the fact that people use and are willing to pay for them gives some indication that people think that images are quite important in a dating app context. Other dating apps in the space have talked publicly about their photo features for a number of years. They've spoke to how, by alternating the first photo which appears in someone's profile, they've been able to improve their match rates. So clearly, photos have been of some importance in the dating app space. But they're not everything. They say a picture tells 1,000 words. There's also a wealth of non-photo profile content that you can put on your Bumble profile. So there's an example of some of the pieces of content here. We have what we call lifestyle badges. So this is where you can put up your religion, whether you drink or not, whether you smoke or not, if you're open to kids. A lot of values-based traits. We also have room for free text content. So you can write a witty bio. We have prompts, which are short questions which elicit witty answers. So there's a lot of room for you to express your personality above and beyond photos. And all these pieces of information matter. You can also connect social media accounts such as Instagram or Spotify. So it's the combination of photos and all this non-photo content that allow you to put forward as rich a perception of your personality as you can on the dating apps. Is anyone here familiar with the concept of above the fold and beneath the fold? Could I get a show of hands? Okay, some of you. So from a kind of product design or product analytics perspective, above the fold is what is visible immediately when you open an app. So in the image on the right here, this is what is above the fold when you're voting on a Bumble profile. So you can see what is pride of place is the first photo. You can see a few additional bits of information like name, age, education, work, employer, pronouns. And then in this example, we've injected a signal of compatibility above the fold. This is a feature we did with Spotify, where we found that by highlighting mutual artists, mutual top artists between you and the people you're swiping on, it led to an increase in match rates. So that's the summation of what exists above the fold. Then on the left, you can see what exists beneath the fold. So this needs to be scrolled to come into view, which is why we call it beneath the fold. And most of that non-photo profile content I described in the previous slide exists beneath the fold. So that's something to bear in mind as we continue through this presentation, that not all profile content is consumed every time you view a profile. So we need to remember that hierarchy as we're thinking about the importance of people's first photos. So before I jump into our initial implementation of the best photos feature, I'm going to describe some metrics that are relevant to what we're trying to do here. So we talk a lot about voting in a dating app context. It's not that we're particularly into politics. It's that every time you view a profile and you decide whether or not to express an interest in matching with them, we call that a vote. Yes votes are where you do have an interest in matching with that person, and no votes are where you don't. So then yes vote percentage is a metric for the amount of yes votes a profile receives over all the votes it receives. As you can imagine, this is quite an important metric to us, and this is one that we were looking to improve when we were thinking about our best photos feature. So yeah, kind of what problems were we trying to solve with it? Well, there's a couple. So As I mentioned, the existence of photo rating websites, what we see is that people's own perception of what is their best photo isn't always what the population thinks is their best photo. So we find that time and time again that the photo that members would put first isn't actually the one that receives the most yes votes. So that's a problem. Equally, the problem space we're operating in, people aren't on dating apps forever. They may only be on them for a few hours, a few days. Depending on where you are in the world, there might be not that many people for you to vote on. So it's a very quick problem we need to solve. From the first time people start voting on you, we want to get you as many yes votes and matches as possible. And to do that, we want to find your best photo as soon as possible. So those were the goals we were trying to achieve. Could I get a show of hands if people are familiar with multi-arm bandit? Okay, good portion of the audience. Data Science Festival, I would expect that. So I'm not an expert on myself. I'm just going to give a bit of a broad overview because it matters for the way we've implemented best photos. So multi-arm bandit is used for kind of continuous optimization problems, particularly when you don't know about the success rate of the individual options ahead of time. So with traditional kind of experimentation or statistical testing, you would pick your number of variants, you would calculate some minimum detectable effects and see what sample sizes you need to reach them, and then you would set your experiment to run for a fixed amount of time, and you would show all of the options in equal measure. However, in doing so, it might be clear from peeking at the data very early on that one option is dramatically outperforming all the other options, or the one option is performing far worse. So in this case, we're doing too much exploration and potentially not enough exploitation. So this concept of exploitation versus exploration is inherent in multi-arm bandits. It seeks to find as quickly as possible the optimal solution to a problem, and then it tries not to miss the best option in doing so, but once it identifies what it thinks is the best option, it seeks to exploit that then to maximize the benefit that is received over the course of this test. I think there's a very nice visual here from KD Nuggets that demonstrates this. So in the image on the left, we've done a little bit too much exploitation and we've managed to avoid the optimal outcome, which is the green star. However, if we have a more lengthy phase of exploration and we consider the breadth of all available options, we're more likely to not incorrectly discard the optimal outcome. So there's an inherent trade-off here. I think this video should play now, which will give an indication of the distributions of the different variants changing over the course of a test rather than being shown an equal amount of times. So this is the basic concept of multi-arm bandit. There are plenty of different statistical approaches to it, which I won't delve deeply into, but I'll give kind of an introduction to three of the main methods or agents for doing it. So we have epsilon greedy. This is fairly straightforward. So a set percentage of times, epsilon percent of times, the model explores what it thinks isn't the best outcome. And the rest of the time, it explores the best outcome. So in terms of balancing the exploration trade-off, you have a lot of control of this through your epsilon value. So if you set the epsilon value to be very low, you are exploiting what you think is the best option for 1 minus epsilon percentage of the trials that you have. If you set your epsilon high, you're doing a lot more exploration, maybe to the detriment of exploitation of your best performing option. Upper confidence bound is fairly self-explanatory. As we know in statistics, when we only have a small amount of samples, it can be hard to infer the shape of the underlying distribution, so we have wider confidence intervals. What upper confidence bound does is it looks across all the arms or variants you have, and it shows the option that has the highest value in its upper confidence bound. So this means that options which haven't been explored too much will be shown a lot more often because they will have a wide range, the upper bound of which may be above options which have been explored more, which have narrower ranges. Then eventually this will converge to what is actually the best option after a certain number of samples have been reached for all of them. But what this means is that as new options get introduced, they'll all be explored a certain amount of times. Thompson sampling is the final one I'll describe. So this is more Bayesian in nature. This looks at the past successes and failures of each distribution. And each time it's deciding what to show, it looks at those distributions, it takes a draw from each of them, and then it just shows the one which had the highest value from that draw. So this means that it will continuously show kind of proportionally what are the best performing options, And then if the prior distribution becomes particularly good for one of the options, it will default to showing almost entirely that, but not entirely that, because every so often some of the distributions with lower mean rates will still get shown. So that's just some of the multi-arm bandit techniques we have. There are deep statistical papers on all of them that I haven't read, so if you're more curious than that, there's plenty of resources to be had. A little bit of housekeeping about how the Bumble feature operates. So it's opt-out, so members are informed during registration and onboarding as they add photos that this feature exists and that they are currently opted into it. At any point in time, they can go to the edit profile page and opt out. However, while this toggle is active for them, we are alternating their first 3 photos to try and find which is the best performing one. So we initially launched the feature a couple of years ago. Originally, we had 2 photos or 2 arms, then we used 3. We were trying to optimize for the metric of yes vote percentage, which I explained earlier. So we use a beta distribution. I'm not sure if people here are familiar with beta distributions, similar to a Bernoulli distribution, but it's where you have a discrete amount of successes and failures. So we were creating beta distributions for these 3 photos. And then every so often, we were running simulations. And we were seeing, when we drew a certain amount of times from these distributions, which photo won most of the time, which photo had the highest yes vote percentage when we drew that. And if we reached a certain level of certainty that a certain photo was someone's best photo, we gave a notification to the member in the front end telling them that we'd found their best photo and put it first for them. So this was successful, and we increased average yes vote percentage. However, we saw that there was room for optimization for members who didn't receive that many yes votes or who had arms that didn't receive that many yes votes. So to make this a bit engaging, I'm going to take you through some of my own data. So these are 3 of the photos that I had operating in the best photos model: photo 1, photo 2, photo 3. Could I get a show of hands for who thinks photo 1 would be the best photo? Okay, not that many. Photo 2? Okay. And photo 3? Okay, this is actually fairly close to the reality. I wasn't expecting that. So as you can see, I didn't know which of these was better myself. I thought pottery might be quite enticing, but clearly not, nor are London landscapes. So I've purposefully omitted the the x-axis here, so you can't see the actual numbers, but you can see in relative terms, photo 2 does perform a lot better for me when it's in the first place. But the point I'm trying to make here more so is, and this is a recommendation I'd give to anyone working in a kind of applied machine learning space, by really understanding your own data and how it features into the model, you're able to get a better understanding of how it behaves in practice. So this really helped solidify my understanding of how the best photos feature was behaving. So then, Bumble Inc. We run a lot of A/B tests. In fact, I think we're only a couple of weeks into Q4, and we're already in kind of plenty of double digits tests this quarter. So these A/B tests generate a lot of learnings for us. They touch different parts of the app, so we might do onboarding tests, we might do pricing tests, but we do a lot of tests on the core voting experience. So this is the main profile, like I showed earlier. We would change the content that appears in it, we would change the order in which it appears. So to really get a granular understanding of what was changing with these interventions, we wanted to get a grasp on the behavioral metrics and how members were interacting with the profile in different ways. So an insight that we uncovered during a few of these tests led to an insight which would be very useful for best photos. So what we found was that a certain UX pattern or implicit feedback behaved as a strong signal of interest in someone's first photo, even if it didn't ultimately lead to them swiping right or having a yes vote. So this was powerful because, as I mentioned, one of the problems we were facing is that certain photos for certain members didn't have that many successes. So by identifying this additional UX data, which was a strong signal of success, we're able to bolster our distribution somewhat. So I might jump to a live demo now, which I believe should be operating down here, so if you bear with me on the mic. So these are beta distributions, as I spoke to previously. Sorry, bear with me. Yes, so everyone can see that. I can see that as well. Okay. So this is a visualization tool. So I've created 3 beta distributions here. I've initialized them with 1 success and 1 failure. So you can see there's just a lot of noise at the moment. So then as the photos receive more votes, you can see that the distributions start to change. So we can see here, this is the photo that wins what percentage of time when we do the simulations. So we can see here that when we added a few no votes for the second photo, this photo no longer becomes the winner as much. If we add more no votes for other photos, we can see that the remaining photo starts to win. So this is how the model behaves in practice, but you can see it can be quite jumpy in the early stages. And particularly, I'm just going to add a few more votes here. You can see that a single success can really push a certain photo ahead. So we might have the case where we have distributions that only have a very small amount of successes, but a very large amount of failures. And it could have been a mistaken vote. It could have been someone who was voting on everyone that would give a particular arm an additional vote. Over time, it does reach more stability. So you'll see now when I add, I'm going to multiply this by a large number, and you'll see that this will have a far narrower. So you can see now this has just blown all the other distributions out of the water in terms of having a narrow distribution. So like over time, as the members receive votes, there'll be more clarity in the performance of the various arms of the bandit. But in this early stages, where it's trying to find the best one, the small amount of successes can be quite problematic. So if I dial it back now to have a small amount of failures for all of them, and I reset this. So we can see here that when we have a few successes at least for each arm, that we have more stability. If we add a single success to one now, it doesn't have as dramatic effect as it does as when there's only one or two successes. So by incorporating this additional UX data, we're able to do quite well to improve the stability of the model in its early stages, and also to have a better consensus on which was the best photo. I might jump back to the other laptop now. So what happened when we did this iteration? So by incorporating this additional data, we increased a variety of metrics, so revenue, engagement, yes votes, which was the main target, and then matches as well. It's very rare that we see such uniform uplift across such a variety of metrics, so this was very encouraging to see. How come we had this increase? Well, we were able to find more best photos for people and find them quicker and earlier in their lifetime on the app. And then what's next for best photos? These learnings can be applied to all the apps within Bumble Inc., and we continue to iterate on the existing best photos feature. So to recap, photos, very important in the dating app space. Testing can be very useful, particularly for the learnings it generates. Bumble Inc. are hiring, and more on that in the next slide. Multi-arm bandit is a very powerful approach for optimization problems where there are multiple arms of which you're unsure of their distribution ahead of time. However, there's a lot of impact to be realized by combining product insights and subject matter expertise or deep understanding of the problem space to which the machine learning models apply. There's a strong synergy to be realized there. So yeah, sorry, I went through that quicker than I thought I would. Yeah, these are just a few links. If you scan the QR code, you can find the Bumble Careers website. We're also hiring across a number of roles. So we have senior machine learning engineers on our trust and safety and recommendations team, senior data scientists in our recommendations team, and an MLOps engineering manager. So I think I have more time for Q&A than I anticipated. So I'd like to open the floor for that. Thanks.
That was brilliant. Thank you. Any questions? Do you want to raise your hand? I've got one here.
Thank you. Hi, thanks. Do you weigh the votes later on? Because some votes might lead to nice connections, some votes might lead to no connections, and that might be quite relevant for your beta distributions. That's
a very good question. So in terms of considering yes votes, we also need to consider, the reciprocation likelihood. So those are kind of two separate targets. So what we see with the photos is whether someone initially expressed an interest in that person, but yeah, you're right, that doesn't tell us about whether the other person is likely to reciprocate it or not. What we tend to find, and something about the best photos feature, which I think is quite elegant, is that it's kind of agnostic of who's viewing it. So this isn't kind of personalized to, oh, we see that you swiped right, and a lot of people with puppies in their photos or on hiking trails, and therefore if someone has a hiking photo, we'll put them first more for you because that's your personalized preference. Like, we have tried collaborative filtering, and it's a bit difficult to produce kind of robust results. So the vote of the population, as we saw in my example, tends to be quite good. And like at a later stage, and then we have different compatibility algorithms for different purposes within the app. We do have different things that are optimizing for matches, but that's more at a kind of an ecosystem or aggregate level than what photos should we show first for you each time. So it's a very good question, and yeah, we're trying to address it in ways outside of photos. The best photos is kind of a general approach to get you more incoming activity, and then yeah, we have separate things which are focusing further down the funnel.
Hi, thanks so much. You mentioned briefly about someone just swiping right or saying voting yes on everyone. Do you filter out those types of users, or how do you handle that?
That's a very good question. Yeah, so say for like reporting purposes, obviously, if the average person votes say 50 times a day, and there's kind of an actor who votes yes 10,000 times a day, that will distort our metrics a lot. So we can do a lot of kind of member level filtering, so we would exclude such outlier type activity from our overall reporting. A lot of what we do as well would be aggregating in averages. So even if one person has a very, very high outgoing rate, what we will see is that when that's averaged across everyone, even if that average isn't reflective of the median, it will be less detrimental than if we do just an overall sum of all yes votes over sum of total votes. So we do have ways for considering it in those realms. In terms of kind of like artificially influencing this model, so by incorporating this additional UX data, those patterns are actually less typical of the people who are just kind of mindlessly voting yes. They wouldn't exhibit those same UX patterns. So this is actually providing more data to help kind of decrease the importance which would otherwise go into those votes. But yes, it is kind of an ongoing thing that we grapple with. We also try and solve it on the the trust and safety side. Some of the reasons we would block actors would be because they're using it for bad purposes, and that's one of the indicators that they are. So they wouldn't be on our kind of platform for very long in any instance. But yeah, no, it's a good question.
Oh, thank you. I imagine you've determined the underlying heuristics of what a good photo is. Do you weight that into like this decision-making process of your like beta testing?
That's a good question. So we don't at present, and I think that like the power of this model as it is like it's entirely agnostic of the content of the image. We might be able to give a more clever kind of starting weight to particular photos if we were able to identify something which like robustly indicated that it was a good photo. We are doing kind of exploratory work in the computer vision space, so technologies like Clip to extract embeddings, or say, for instance, that this is a hiking photo or that this is me cooking or something like that. However, kind of the devil can be in the detail with these sort of things, and if you have a very blurry, grainy photo of you cooking that's out of focus versus professionally taken one with a very nice apron on or something like that, the same information we could extract about those photos would actually yield to different results in practice. So the model has been performing quite well without making any assumptions about that, but definitely in terms of, I do believe we have some resources in terms of giving like kind of qualitative advice to members, and a lot of the kind of the stereotypical advice, or like what you would take to be platitudinous advice, does apply. It's just like good quality images, clear, not large group photos where it's unclear who you are. less gym selfies, more kind of active shots. Like all of that, fairly anecdotal, fairly qualitative, but we would give that general advice to people. And then, yeah, among the, like I said, I think one of the advantages of the model is that it's entirely agnostic of that. But definitely there could be a way that in a future where we get very, very good at personalization, that we could see that all things equal, if there's a hiking photo, let's show that to you. But we're not at that stage yet.
How do you make sure the voting is normalized from ethical perspective, responsible perspective, and also from it's not biased?
So kind of biased in terms of informing the model, or just in general?
Bias could be regional, religion, color, race.
That is a kind of a tough question to answer. So we don't currently use any sort of like protected characteristic in any of the decisions we make in terms of who to show. It's fairly, the two primary filters we have are kind of distance and age. So you set those filters, and then we just show you people in a particular order. We try and take compatibility and things into account. So we don't explicitly capture any kind of features which would be prone to bias within that. Like our mission statement, as was on one of the previous slides, is to create a world where all relationships are healthy and equitable. So we are, it's more a consideration for like AI models where we would put in features that might together be given some kind of bias. So we do have kind of ways of dealing with that. But when it comes to the core voting experience, there's not that many characteristics in it that could kind of be used as features to contain bias. It's fairly, if you're in a very small part of the world, we'll show you the people in that area, and I mean, you'd be biased towards being in a small area in that scenario.
These are all very good questions. Are you happy to take one or two more?
Yes.
Yeah, we've got time for it. Should we take?
Hi, thank you. Very interesting presentation. I just wanted to ask, because you mentioned you're optimizing for number of votes, and also a separate metric would be whether they're reciprocated, but also do you optimize for whether there is a meaningful conversation after that, or whether it's just a match and is being left? So do you measure success also on a basis whether there is a conversation and interaction going after that?
That's a good question. So we have the concept of a dating funnel or a matching funnel. So originally it's you vote, then is it a yes vote, then is that voted back on by the other person? Is that yes or no? Does it lead to a match? Does on Bumble the woman make the first move? Does the guy reply? Does the woman subsequently reply? So you can imagine it gets a lot narrower as we go down to that. So we do keep an eye on the percentage of conversations that we think have had some meaningful level of interaction. It's a hard thing to gauge, however, because to anyone who's kind of used dating apps or has met their partner through it, after a certain length of time, you delete the app and you just converse via other means. So we can see sometimes that, a conversation has gone on to this length, and then obviously GDPR, we can't see the content of messages, but we have certain like kind of aggregations, or something that looks like a number was shared here, assumedly then maybe they started texting. So we kind of keep an eye on that overall, but that as like, by the time the funnel gets that narrow, there's a very small amount of positive samples. So we wouldn't want to dramatically reduce the efficacy at any stage in what we do, but we find it's kind of easier to focus higher up the funnel, and then we kind of have guardrails on if we do something that like dramatically impacts the distribution, such that certain people are overwhelmed with messages they can't reply to, and the metrics would dip then like that's not a good thing to do. But typically no, because it's such a kind of small amount of samples, it's more effective focusing where we have more training data. So yes, it's matches primarily, and then we do keep an eye on the chat funnel thereafter, but the proportion of, say, yes votes that end up at that stage, it's a kind of a very small percentage, so it's very, very hard to get enough signal from that to be entirely predictive at that point.
Very clear, thank you.
Okay, final question. I'm going to take one from the back because I've been in the front for quite a long time. Right at the back, perfect.
So my question is, have you considered I know it's going to sound bad, but like a worse photos kind of aspect, as in you do this testing on 3 random photos from the selection, and if one of them is massively underperforming, telling the user and letting them know so that they can change it and not have like a really bad picture in there.
That is a great idea, and one I had myself after looking at how much more poorly my 2 non-best photos were doing. So I can't comment on things that may be in active development, but when we're looking at photo-related stuff, that is a consideration that crosses our mind as well, for sure. Great idea.
Well, thank you very much. Let's give Dónal a round of applause again. Thank you. We're just going to take a quick 5 minutes to change over to our next speaker and see you around.